Hi, and thank you for clicking on this video, and welcome to integral of symmetry. Integral of symmetry is a new method in order to calculate any primitive of any function in any dimensional space. And in this third video, you are going to be the witnesses of the amazing power of this approach. And we are going to calculate our first volume without using multiply integral, because we had a new approach that allow us to have our own concept in the dimensional space that we are working about. We are going to calculate the volume under this surface z equal s dsy equal a square root of 7s plus 5y 2 5, and we are going to use our first formula for primitive of the linear function and any power of that linear function, our identity function, which is integral of s plus y to n dsy triangular expansion equal s plus y to m plus 2 divided by m plus 2. But we are going to generalize that formula with coefficient in s and y. That is to say, we have integral of 8s plus by to n dsy triangular expansion equal 8s plus by to m plus 2 divided by 8 times b times m plus 2. This is our generalized formula for a triangular expansion of the any power of the linear function, which is a plane. But now with the power, is no longer a plane, it's a curved surface. Now we can use this formula in order to calculate the primitive of that function, that is integral of 7s plus 5y to 5 half the sy triangular expansion is going to be equal to s to 7s plus 5y to 5 half plus 2 divided by 8 7 b 5 times 5 half plus 2, and making the operation we have 7s plus 5y to 9 half divided 35 times 9 half. And if we want to calculate, for example, this volume between two planes, just like 7s plus 5y equal 3 and 7s plus 5y equal 5. This volume we can visualize it by this diagram. As you can see, this diagram, the volume that we are going to calculate it between the two planes, and under the surface we represent our function z square root of 7s plus 5y to 5. Well, only that we are going to do is replace 7s plus 5y for these two values, and we have only that we have is 7s plus 5y to 9/2 divided by 35 times 9/2 between 7s plus 5y equal 5 and 7s plus 5y equal 3, and this is 5 9/2 minus 3 9/2 divided by 35 times 9/2, and making the operation we have 7.98. This is the only that you have to do in order to calculate that volume. If you tried to calculate the same volume by the same procedure of the multiply integral, you had to first divide the region in two parts, and you had to resolve two integrals for resolve that problem. And you had something like this integral that you had to solve in order to calculate with the old method that we inherit from Newton and Leibniz of the multiply integral. As you can see, it's not easy to resolve for this method. For that, you are a witness of the power of this method in order to make easy the calculus of the volume. Thank you so much. And in the next video, we are going to extend our kind of expansion, because this is the triangular expansion, but actually in three-dimensional space we have infinite kind of expansion. And in the new video we are going to see the circular and elliptical expansion, and you will be surprised of the power of this method in order to resolve problems that are difficult to solve. Thank you so much. I hope you to be in the next video.